You know, when someone with like 30 years in applied intelligence research and who's also an active enterprise CTO calls a new tech a quantum leap, you really have to stop and listen.
Oh, absolutely. That phrase, it's not just buzz. It's a serious signal in this whole AI trust minefield we're navigating.
Right. And that kind of independent validation, especially from someone with that background, it doesn't just, add to the discussion. It kind of sets the stage. It helps define the whole narrative for the industry.
Exactly. It's like the permission slip that risk-averse leaders, especially CTOs, need.
Mm.
They need that solid authority before they even think about making a big architectural shift.
Yeah, that one credible voice can give them the backing they need internally.
Precisely. Gives them the mandate to actually move.
So today, our mission is really to dive deep into the specific endorsement. It's an independent technical review, a validation of something called the Fractal Identity Map, or FIM.
Uh-huh.
We want to unpack what FIM is, its software side, but also how it connects with hardware to tackle that huge AI black box problem.
And maybe touch on what this validation could mean for, well, what some are calling a potential $100 billion market in verifiable compute. It's pretty significant.
Definitely. But let's start with the problem FIM is trying to solve. The review really hammers this home, right?
It does. The core issue, the sources really emphasize this, is that current AI systems just fail a basic, really fundamental test. Prove what data you used. Show me why your AI decided that.
And right now, pretty much every major AI system, well, it can't do that. Which sounds maybe academic, but the fallout is very real, very financial.
Oh, it's measurable, all right. And it's painful. The sources mention businesses losing up to 40% of customers. Not just because the AI messes up, but because there's this basic lack of trust.
And the regulators are watching closely.
They are, and they're acting. We're talking real enforcement, serious fines. The review even calls out specific examples like 35 million fines for non-compliance, keeping things opaque.
Yeah.
It's just not financially viable anymore, especially in regulated sectors.
Okay, so the person doing the validating here is key. They're the catalyst, you could say. Who exactly has the kind of authority to give this sort of green light?
Well, their credibility comes from this really rare mix of expertise. It's quite something.
Yeah.
Okay, so first, 30 years as an applied intelligence researcher, deep theoretical understanding, right? Mathematical rigor.
Okay, the academic chops.
Then they're also an active enterprise CTO, so they get the real world stuff. Implementation risks, speed, ROI, what actually works in a business.
Right, practicalities.
And this is crucial. They're also a hardware security specialist. Deep, deep knowledge of things like trusted execution environments, Ts.
Wow, okay, that is a unique combination. Bridging theory, business, and the actual silicon security. That's not common.
Not at all. They see why software-only fixes just won't cut it for trust. They connect the enterprise needed, speed, results of that academic depth, and the hard reality of hardware security.
And that's what makes this validation so authoritative.
Exactly. It establishes that.
Yeah.
That validation threshold the industry needs to really see FIM as a serious foundational answer.
Okay, so let's get into FIM itself. If we agree the black box is broken, FIM is put forward as the software fix. What is it, fundamentally?
So FIM, the Fractal Identity Map,
Hmm.
it's a patent-pending way to fundamentally reorganize information. Think of it as a framework
A framework.
for organizing data into a multidimensional kind of fractal hierarchy. And it does this using something called self-legending semantic addresses.
Okay, self-legending semantic addresses. Break that down. Sounds like coordinates that describe themselves.
That's a good way to put it. Think of a normal IP address. It just tells you where data is, right?
Right.
A semantic address is more like a self-describing GPS coordinate. It tells you what the data is about and how it relates to everything else in the system. It encodes meaning and context right into the structure.
So the goal is to make complex stuff like exactly how an AI made a decision transparent just by how it's structured, auditable by design.
Exactly. Transparent by design, not as an afterthought.
Yeah, structure is one thing, but the review really highlights this efficiency formula. That sounds like a big deal, especially compared to how AI often searches linearly now. How does FIMOM change that search process?
Yeah, this is where that quantum leap comment probably comes from. The review confirmed this exponential query efficiency formula, CTN.
Okay, CTN. What do C, T, and N represent?
So roughly C is the number of categories relevant to your query. T is the total number of categories in the whole system. And N is how many dimensions your map has.
Mm-hmm.
Because the structure is fractal and has meaning built in, you don't search linearly through everything through T.
Yeah.
You only navigate the relevant branches defined by C.
So complexity doesn't just grow with more data, it actually gets better the more specific your query is. Like you're cutting down the search space geometrically.
Precisely. You prune the search space
Yeah.
before you even start the heavy computation. This massively cuts compute costs, reduces memory needs, and improves scaling in a way current methods just can't match.
So you get speed and full traceability.
That's the core idea. Speed, scale, and accountability, all baked in.
Makes sense for searching, but building that complex hierarchy sounds like it could be slow to index up front. Is there a trade-off, like slow start for fast queries?
That's a really important point, and the architecture addresses it. The review confirmed another core innovation here, something called short-rank, short-lex ordering.
Short-lex ordering.
Yeah.
Okay. How does that help with the indexing speed and complexity? Can you give an analogy?
Okay. Imagine organizing a huge library. Alphabetical order, the usual way, is linear. Adding one new book means finding its single exact spot globally, right?
Yeah, could take a while in a massive library.
Shortlex is different. It orders things based on their semantic weight, basically, their meaning or importance within the structure. It groups similar concepts together first.
Ah, so it narrows down where a new item might fit.
Exactly. It makes the potential insertion points much smaller, more predictable. It mathematically limits the worst-case time for sorting and adding things, which means it can scale even when the total data grows like crazy.
Okay, that makes sense. Which brings us to what the validators seemed most excited about. The hardware connection. FM is the software blueprint, but software alone can be dodgy. This is where T's come in.
Absolutely. This is the linchpin. The validator literally called FEM, paired with T's like Intel SGX, RM Trust Zone, AMD SEV, a match made in secure computing heaven.
Secure computing heaven, huh?
FEM gives you the structured, understandable maps. The T's give you that isolated environment to prove cryptographically that the map is genuine and wasn't tampered with.
So a division of labor. FEM organizes the knowledge, T's lock it down and prove it.
You got it.
Here it
This is how you move AI accountability from, just trust us to here's the proof. The expert actually described it as the software blueprint for transparency paired with hardware's ironclad enforcement.
Let's dig into the ways the review confirmed this works in practice. 3 main pathways, right? First one is tamper-proof mapping inside these enclaves.
Yes. For the accountability to stick, the FEM maps themselves have to be generated and updated somewhere completely secure. So the FEM calculations run entirely inside the TE.
Inside the secure hardware bubble.
Exactly. The enclave makes sure nothing external, not malware, not the operating system, not even the hypervisor, can mess with or spy on the map creation. It's built clean.
Okay, but how do I, sitting outside, maybe I'm an auditor or an insurance company, how do I know that bubble actually did what it was supposed to do?
Wow, that's the second pathway.
Right.
Cryptographic attestation. This is key. T's have protocols, like Intel SGX's remote attestation,
Right.
that let the hardware generate a kind of cryptographic receipt. It proves to an outside party, you, the auditor, the insurer, that this specific map was genuinely created inside a real untampered TE running the correct code. It's a hardware-backed proof of authenticity, unforgeable.
Got it. Hardware proof. And the third pathway, real-time checks.
Yeah, real-time drift detection. Since the hardware enclave is isolating the FEM process anyway, it can also be set up to monitor what that process is doing.
Right.
Like, are certain operational limits being hit? Is the AI suddenly trying to access data it shouldn't? Or maybe doing a calculation that's flagged as risky?
And the hardware catches this directly.
Right. The hardware itself can monitor for these threshold breaches and log them, or even halt the process, without relying on the potentially compromised AI software to report on itself. It provides ongoing integrity checks.
Okay, let's make this concrete with the examples. Generative AI, huge risks around copyright, data usage. How does FIMT help there practically?
Well, the sources describe a really interesting application. You could use FIM to structure, say, an LLM's model weights, or maybe its attention mechanisms, creating these fractal maps inside a T.
Okay.
Then, when the model generates text, the FIM-T combo can cryptographically attest that it only used the properly licensed training data subset during that specific generation process, not the whole messy, potentially infringing data lake.
So it provides proof of compliance for content generation.
Exactly. Reduces risk dramatically. And, as a bonus, leveraging FEM's query efficiency inside the T could help manage those massive LLM compute costs, too.
And what about that enterprise example, the AI hiring tool facing bias concerns?
Yeah, that's a great one for showing provable governance. The AI tool's decision logic, maybe how it weighs factors related to, say, ethics.fairness, bias mitigation, That whole path gets mapped by FIM inside a secure T, like an ARM trust zone core.
Okay.
The hardware then effectively seals that decision path. Later, an auditor can query that attested map. The hardware proof shows the process stuck strictly to the approved ethical parameters. No hidden biases creeping in, no unapproved changes, hardware-verified fairness.
And this level of proof, this verifiability, it clearly translates into money. The validator wasn't just confirming the tech works, they were projecting a massive market opportunity this unlocks.
Oh yeah, this is the big number. The validation backs up this prediction of a $100 billion plus market just for verifiable compute by 2030. That's huge.
100 billion. So this isn't just about avoiding fines. It sounds like it enables totally new financial products.
That's exactly right. The idea is that FIM flips traditional trust economics. Opaque AI models are mostly liabilities right now. Verifiable FIM-T systems turn them into insurable assets.
Which opens the door for things like, what was it, parametric AI insurance?
Yes, parametric AI insurance. Crucial concept here.
Explain that for us. How does it differ from normal insurance?
Okay, so traditional insurance for AI failure, it's messy. Subjective investigations, arguments about cause, takes forever.
Right.
Parametric insurance is different. It pays out automatically based on a specific, pre-agreed, verifiable event or data point, no investigation needed.
And with FIM-T,
The attested FIM map, verified by the T's crypto code, becomes that verifiable data point. Reinsurers can query the hardware-attested map. Did the AI perform within its guaranteed operational limits? Yes or no. If the verified metric shows it breached the limit, bang, the policy pays out instantly.
wow. So it directly links proven performance to financial risk and reward.
Precisely. It makes AI risk quantifiable and transferable in a way it just hasn't been before.
So for CTOs listening, the takeaway seems pretty clear. This FIM-T combination isn't just about ticking compliance boxes, it's got tangible benefits.
Yeah, absolutely. For those in regulated fields, healthcare, finance, it's a potential path to satisfying zero-trust mandates because the trust anchor is in the hardware. That's compelling.
And beyond compliance.
Well, there's that quantifiable ROI from the exponential performance boost we talked about. Faster, cheaper compute plus hardware-backed accountability plus insurability. That's a powerful combo.
And the review also mentioned a strategic angle to this validation release. It's not just about selling FANA right now.
Right. It's framed as more of a movement strategy. The first step isn't pushing the solution, FIM, down everyone's throats. It's about getting industry-wide agreement on the core problem.
The prove what data you used problem.
Exactly. Getting key people to acknowledge that current systems failed this fundamental test. This expert validation serves as that crucial nod, that institutional backing. It lets tech leaders publicly say, yes, this is a real crisis, and start building a community around finding solutions. FIM is then positioned as the proven blueprint for that solution. Build the consensus first.
Makes sense. Build the demand by validating the need.
Build the coalition naturally.
So we've gone from this intricate software architecture, through its synergy with secure hardware, T's, all the way to a potential $100 billion economic shift based on verifiable proof.
Yeah, the validation really paints a picture of moving AI from what feels like probabilistic guesswork towards something more like geometrically provable insight.
The key being AI that's hardware verified by design.
And there's this final, really thought-provoking comment the validator made, connecting this tech shift to something much bigger, much older. They noted that this whole transformation grounding trust, not in centralized authorities or opaque software, but in provable physical hardware. It kind of echoes this long historical struggle. They called it an answer to Moosman's 5,000-year challenge to centralized trust.
Wow. Okay, Moosman's challenge, rooting trust in the physical layer. That definitely gives you something to think about.
It does.
So a final thought maybe for you, the listener. What really changes when accountability, provable accountability isn't just an abstract promise, but it's literally embedded in the silicon? What does that mean for everything from business to security, maybe even democracy? Something profound to consider as this verifiable compute market starts to unfold.